Hello everyone, myself Patil AS from SGM College, Karad. At a previous lecture, we discussing about the solutions or vapor pressures. Now in this lecture, we start the new point, that means ideal solutions and non-ideal solutions.
For that, we take two volatile liquids, liquid A and a liquid B. Liquid A and liquid B, we mix each other and form a solution of AB. That means it's our solution of these two volatile liquids. According to Rolle's law, we write the total pressure of the solution is equal to the addition of these two pressures of a liquid A and of liquid B, PA plus PB. By putting the values of PA and PB, here value of PA is P0A into XA plus P0B into XB. See here, from this equation, we understand the value of PP, that means total pressure of this solution is equal to the pressure, addition of these two, pressure on A as well as the pressure on B.
In our textbook, they write as for a liquid A 1 and for a liquid B they write 2.
Experimental value and if we write the values of each, that means P0A, XA, P0B and XB, putting these values in the equation and find out the value. This value is known as a calculated. Calculated value. If both values are same, that means it's experimentally checked the value of that total pressure is equal to the calculated value of these, or then this known as that solution obeys Rolle's law. आता दिलेले जे सोल्युशन आहे त्याचा आपण टोटल प्रेशर काढलं आणि हे एक्सपेरिमेंटली इन्स्ट्रुमेंट वापरून आपण एक्सपेरिमेंटली कॅल्क्युलेट केलं. ती व्हॅल्यू जर दिलेल्या व्हॅल्यूज पुट करून आपण जी कॅल्क्युलेटेड व्हॅल्यू काढली त्याच्याशी इक्वल असेल, बोथ आर इक्वल, देन दॅट सोल्युशन ओबेज रॉल्स लॉ. आता ते सोल्युशन जर रॉल्स लॉ ओबे करत असेल तर त्या सोल्युशनला आपण आयडियल सोल्युशन असं म्हणणार आहे. नाउ बाय द सेकंड, enthalpy of mixing is equal to 0, that means delta mixing H is equal to 0. How? See here, if we are taking the solution, two molecules of A, that means solvent, it is our solvent, solute and solution. See here, AA, two molecules of solvent are bond each other. B, that means two molecules of solute we are taking, and AB. या सर्वांमध्ये कुठला तरी बॉन्ड असणार आहे. AA मध्ये एक बॉन्ड आहे, BB मध्ये एक बॉन्ड आहे, AB मध्ये सुद्धा एक बॉन्ड आहे. हा बॉन्ड आपल्याला काय करायचं आहे, ब्रेक करायचा आहे. वी वांट टू ब्रेक दॅट बॉन्ड बिकॉज if this bond is break, then that A will be attached to that of B in a form of solution. Mixer तयार करण्यासाठी आपल्याला यामध्ये काय केले पाहिजे, बॉन्ड ब्रेक केले पाहिजे. When we want break this bond, then that solvent absorb the energy. For breaking the bond, that is solvent absorb energy. That energy, if we write T energy, that is our E2. In a case of the solute and solvent, they absorb energy for breaking of bond. But in a case of the solution, it will be evolve the heat. It will be given out. But how many heat will be absorbed by solvent? How many heat will be absorbed by solute? The value of these two is equal to the heat evolved by that or heat given by that solution. That means E. That value of E is equal to E1 plus E2. Both energies are same. Then the heat enthalpy of mixing, that means delta mixing H is equal to 0. Is equal to 0. Now the next third point, from these we understand that solution is ideal solution. The value of E is equal to, that means both energies are same. Then that solution is our ideal solution. Now third will be if the volume solute आणि solvent जेवढा घेतलाय त्याचं जेवढं व्हॉल्यूम आहे तेवढंच आपलं सोल्युशन फॉर्म झालंय त्याचं जेवढं व्हॉल्यूम असेल म्हणजे if we are taking 10 ml of solvent, 5 ml of solute, then the total volume of the solution, if that volume becomes 15 ml of the solution, then that is our ideal solution. See here, the value of V means volume of solution, we write it as Vs, is equal to addition of V1 or Va plus Vb. If the Vs minus Va plus Vb is equal to 0, then that solution is our ideal solution. बघा व्हॅल्यूज टाका. Vs किती आहे 15 आहे टोटल व्हॉल्यूम. दोन्ही मिक्स केल्यानंतर येणारा व्हॉल्यूम किती आहे 15. Va म्हणजे आपलं सॉल्व्हंट व्हॉल्यूम किती आहे 10. 10 plus 5 it is 15. 15 minus 15 is equal to 0. If the value of delta mixing is 0, then that solution is our ideal solution. And the last part, from these we understand the energy required for bonding each other or releasing the bond. The molecular interaction is comparable. म्हणजे जेवढा बॉन्ड यांच्यामध्ये ब्रेक करण्यासाठी जेवढी एनर्जी लागली तेवढीच रिलीज करण्यासाठी किंवा त्याचं सोल्युशन बनवण्यासाठी जेवढी एनर्जी लागली त्यालाच आपण काय म्हणणार आहे मोलेक्युलर इंटरॅक्शन आर कंपॅरेटिव्ह. दोन्ही काय असले पाहिजे इक्वल. हे जर चार्ट फॉलो करत असेल तर ते सोल्युशन आपलं कसं असणार आहे आयडियल सोल्युशन.
In a case of an ideal solution, if we take an example for the volume increase, why these solutions are known as an ideal solution. See here, if we take an example of A liquid and B liquid, and if we adding these two liquids A and B, A be the solvent and B is the solute. If we adding the solute into the solvent, the main solution which have the same proportion, if we compare the A, it is equal to reactant, and in a B it is also equal. That means no change into the volume of solute as well as the solvent. If they are mixed, we are getting a similar proportion of that. Ideal solution obeys the Rolle's law over entire range of concentration. No heat is evolved or absorbed when two components forming an ideal solution are mixed. Thus, the enthalpy of mixing is 0. That means the value of delta H is 0. There is no volume change when two components forming an ideal solution are mixed. Thus volume of an ideal solution is equal to the sum of volume of two components taken for a mixing. Delta mixing V, that is 0. No change into the volume. In an ideal solution, solute solvent, solvent solvent and a solvent solvent molecular interaction are comparable.
Ideal solution obeys all these 4 points. For non-ideal solution, when we can say is that solutions are non-ideal. According to Dalton's, we write total pressure, total vapor pressure of the solution is equal to pressure of A plus the pressure of B. We are taking two polarized liquid A and B. According to Raoult's law, we write PT is equal to P naught A into XA plus P naught B into XB. Now see here, similar to ideal solution, we calculate the value of PT by the experiment. And this value will be calculated value. See here what happened? The experimental value and calculated value both have a difference. That means this value is greater than that of a calculated value, or this value is less than that of a calculated value, depending upon these equations. That means the value of a PT is greater than that of a calculated value, or PT is less than a calculated value. आता या कॅल्क्युलेटेड व्हॅल्यू पेक्षा एकतर टोटल प्रेशर काय असणार आहे, जास्त असणार आहे किंवा कमी असणार आहे, इक्वल नसणार आहे, म्हणजेच आपला रॉल्स लॉ ओबे करत नाही. असे जे सोल्युशन्स आहेत त्यांना आपण नॉन आयडियल सोल्युशन्स असं म्हणणार आहे. सेकंड बघा, आपण काय बघितलं, फॉर ideal solution enthalpy of maximum is 0. That means the value of delta mix H is equal to 0. But in the case of a non-ideal solution, what happens? See here, AA, that means our solvent, BB, our solute, and A and B. If interaction or a molecular force between the solute and solvent, that means our solution is V, the bond enthalpy, that means molecular force or molecular interaction is strong into the solute, is strong, then all the value of delta H or delta V we see here. For breaking of this bond, it requires more energy as compared to the making of a bond. Bond break करण्यासाठी एनर्जी जास्त लागणार आहे, म्हणजेच E1 plus E2 ची व्हॅल्यू as compared to that one is higher. If we considering the volume VA plus VB is not equal to the VS or V mix or mixture, we write as is not equal, then that solution is a non-ideal solution. आता हे जे आपण इक्वेशन्स बघितले किंवा the value of PT is not equal to that equation, from these the non-ideal solutions have two different deviations, that means positive deviation and negative deviation. When we can say is that a positive deviation and a negative deviation, see here, the value of a PT, that means total pressure, is greater than that of a P0 A into XA into P0 B into XB. The deviation is positive deviation. If this value is less, PT is less than P0 A into XA and P0 B into XB, then it is our negative deviation. Similar to that, for energies, the value of, see here, if the bond or a molecular interaction of a solvent and solute is stronger as compared to that of a solution, then that deviation, that means delta mix H is greater than that of a 0. Greater than that of a 0. Here also we write the value of PT is greater than 0 and PT is less than 0. Here, if the value is greater than 0, then it is positive deviation, while the value of delta mixing H is less than 0, then it is a negative deviation. Energy value E1 plus E2 is a value 0 पेक्षा जास्त असेल, म्हणजे आपली डेल्टा H ची व्हॅल्यू आपण कॅल्क्युलेट केलेली, ही जर 0 पेक्षा जास्त असेल तर त्याला आपण पॉझिटिव्ह डेविएशन म्हणणार आहे, 0 पेक्षा कमी असेल तर निगेटिव्ह डेविएशन. सिमिलर फॉर द व्हॉल्यूम, डेल्टा मिक्सिंग ऑफ V is greater than 0. Greater than 0 म्हणजे
non-ideal solutions. These solution do obey the Raoult's law over the entire range of a concentration. The vapor pressure of the solution can be higher or lower than those of a pure components. Deviation of Raoult's law. If the deviations are having the values greater than 0, then that is a positive deviation, and a less than 0, that is negative deviations. Here we see, if we comparing by the volume, then easily understand what is mean the positive deviation and negative deviation, when we can say is the positive and negative deviation. Here, when we take a mixture of A and B, the volume of A, when we mix into the volume of B, that means VA plus VB, the total volume, entire volume of the solution will be increases. That means the value of delta V is increases. Then that type of a deviation is our positive deviation. The VA plus VB, at this range we want that solution becomes, but the volume will be increases. Then that type of a deviation is positive deviation. While if that value, if we adding the A and B, when we want to prepare the mixture of these or a solution of these, and the volume will be decreases. That means we want the solution up to here, but the volume will be decreases. Then that type of a deviation is our negative deviation. How we plot the graph of the positive and negative deviation, we will see.
Non-ideal solution मध्ये आपण दोन प्रकारचे deviation. How we draw the graph of a positive deviation and negative deviation. We see here, for that graph we draw on x-axis as a mole fraction and on y-axis we take a vapor pressure. We draw the graph for A and B simultaneously. See here, the value of mole fraction of liquid A is equal to 1 starting from this solution mix होत जातानाच्या व्हॅल्यू आहेत त्या B घेणार आपण, we write as liquid A and liquid B. Therefore here no B will be added here. XB is equal to 0. How we write the value of XB is equal to 0? See here, XA into XA plus XB is equal to 1. Here we write the value of XA as 1 plus XB is equal to 1. XB is equal to 1 minus 1. The value of XB is equal to 0. Similar to that, here what happened? The value of XA is equal to 0 and the value of XB becomes 1 for a liquid B. The pressure, vapor pressure of a liquid A is a P naught A, while the liquid B is a P naught B. Now join these all. There is a question, why we write PA at upper side and PB at the lower side? No matter where they are present. The liquid which is more volatile, then we write at the upper part, and which is a less volatile, write on the lower. जे लिक्विड जास्त volatile आहे ते आपण वर लिहिणार, त्याचं वेपर प्रेशर जास्त असतं, आणि जे लिक्विड लेस volatile आहे त्याचं वेपर प्रेशर काय असणार आहे, कमी असणार. Joining these P0 and P0B, that means our PT is equal to PA plus PB. Now we have a graph for a positive deviation is a PT greater than 0. Positive deviation मिळते म्हणजे PT ची व्हॅल्यू काय आहे, या 0 पेक्षा जास्त आहे. जर हे 0 असती आपल्याला ग्राफ असा मिळाला असता की व्हॅल्यू काय झाली असती, 0 झाली असती, मग हे सोल्युशन आपलं ideal solution झालं असतं. But here non-ideal solution having value greater than 0, therefore we are getting a positive deviation. Now for the negative deviation, similar graph we draw here for liquid and liquid B. Vapor pressure, here we are taking mole fraction. The values of XA is equal to 1, XB is equal to 0, XA is equal to 0, XB. Now for a liquid A, P naught A value, liquid B, P naught B value. Join these all. Now the value for a PT is equal to PA plus PB. For negative deviation, the value of PT is less than that of 0. Therefore, we are getting a negative deviation. Negative deviation. हे जे तुम्हाला खाली दिसतोय कर्व त्याला आपण negative deviation असं म्हणणार. These two graphs are most important.
For a positive deviation, how the graph will be plotted, we discussed in previous video. In our textbook, the value of a PA as written as a P1, that means pressure for the first solution and pressure for the second solution is the P2. We get the deviation here, positive deviation, while here we are getting a negative deviation. Most important, both are the graphs are most important graph. In this lecture, we complete all the points of ideal and a non-ideal solution. One more question will be asking, that means write the difference between ideal and a non-ideal solutions. Thank you.